Hi, welcome to the third day of chapter 14, which is the second day of chapter 14.2. Today we're going to learn about the chi-square test for association and independence. We use this chi-square test for independence or association to test whether the null hypothesis, there is no association between these two categorical variables when you have a two-way table from a single SRS with each individual classified according to both categorical variables. I'll explain this a little bit later on. But first we're going to go through a problem. This is very similar in how we do it from yesterday's, the test of homogeneity. So the question here is, does having exclusive territory help a franchise succeed? So what this data is from businesses where they had franchise. The problem is many popular businesses are franchises. Think of McDonald's. The owner of a local franchise benefits from brand recognition, national advertising, and detailed guidelines provided by a franchise chain. In return, he or she pays fees to the franchise firm and agrees to follow its policies. The relationship between the local entrepreneur and the franchise firm is spelled out in a detailed contract. One clause that the contract may or may not contain is the entrepreneur's right to exclusive territory. This means that the new outlet will be the only representative of the franchise in a specified territory and will not have to compete with other outlets of the same chain. How does that presence of exclusive territory clause in the contract relate to survival of the business? A study designed to address this question collected the data from a sample of 170 new franchise firms. Two categorical variables were measured for each firm. First, the firm was classified into successful on basis of whether or not they were still franchising at a certain date. Second, the contract each firm offered to franchises was classified according to whether or not there was exclusive territory in the clause. So here we have success, and here we have exclusive territory. So this is the data. So if we want to check this, let's make our test. So our null hypothesis is that these two variables are independent. So we'd say success and exclusive territory are independent. And our alternative hypothesis is that they're dependent. So success and exclusive territory are dependent. Alright, so now we have to look at our conditions. Now this data does come from a random sample. I just didn't write down the whole problem. And then we have to check if how many counts there are here. And especially in a 2x2, all of the expected counts have to be greater than 5. So take a second and let's figure out these values. So if we want to find the expected count, if I want to find the count up here, I take 142 times 123 divided by 170. This one would be 28 times 123 over 170. This one would be 142 times 47 over 170. And this one would be 28 times 47 over 170. Now take a second and do these. The values are 102.7, 39.3-ish, 20.3, and 7.74. So since all these are greater than 5, then we can continue with the problem. All right, so now we go on to calculations. Now for the calculations to find our value, we always take the observed minus expected, square that over expected. So, and then add them all up. So it's the sum of all of those. So this would be 108 minus 102.7. Square that, and that should be over 102.7. Add that to 15 minus 20.3 squared, all over 20.3. Add that to 34 minus 39.3 squared, all over 39.3. And then finally, 13 minus 7.74 squared, all over 7.74. And when you add these all up, we get 5.91. And what I would do is do a chi-squared CDF, and that would give us a p-value of 0.015, I should say. So this is 5.91, to a very large number, and our degree of freedom here is 1, because n minus 1 minus the rows, 1 minus the column would be 1 times 1, which is 1. So with a degree of freedom of 1, p-value is equal to 0.015. So for interpretation, we would say we reject the null hypothesis because the p-value is so low, 0.015. So we have evidence that exclusive territory has an effect on success. All right, so that is the chi-square test for independence. So now we have 3 different chi-square tests. The goodness of fit test, we can tell because there's one list. So we put all these values in L1. And on our calculator, some people have a goodness of fit test on their calculator, where you just put the value into L1. Not everybody has that. If not, you have to do the observed minus expected squared over expected, add them all up. Homogeneity. Homogeneity, the chi-square test for homogeneity, we have a two-way table, and we have multiple SRSs. So this is a case where we took a couple of different samples, and we're comparing different samples. Where the test for association, we have a two-way table, and all of the data comes from one SRS. So to use the examples that we used in the lesson, for homogeneity, we did um, a question about um, wines, where we got one set of data from when the music was playing French, or from when they played French music, what people bought. Then they played Italian music and watched what people bought, and then they played no music and watched what people bought. So there was three samples that were taking place. If we do the association or independence test for chi-squared, all of the data comes from one SRS. So all of this data here, um, they took one SRS, asked people questions, and each person fit into one of these categories. Either they were here, or here, here, or here. All right, now that's the difference of the three chi-squared tests. Here's your homework. Good luck.